All right, let's just jump right in. Welcome to the Explainer. Today, we're unpacking an absolute paradigm shift in the big data ecosystem. We're talking about the evolution of DuckLake. This started as a bit of a rebellious pushback against how modern file management architectures are built. And now it's hit that highly anticipated 1.0 release. If you're working with data lakes, this architecture shift is something you absolutely cannot afford to ignore.
So, here is exactly how we're going to break this down today. First, taming the file zoo. Then, the 1.0 milestone, killer new features, real-world Duck Lake, the iceberg puzzle, and finally, what's next for 2.0. All right, Section 1, taming the file zoo. Let's look at fixing modern data lakes.
Okay, let's think about the core problem with traditional data lakes today. The creators of DuckLake looked at formats like Iceberg and Delta and realized something kind of troubling. These modern systems rely heavily on what we can call a data file zoo. I mean, literally thousands of tiny JSON and Avro files just floating around to manage metadata, plus this whole complex REST server architecture to make it all work. The DuckLake team, who are total database purists, by the way, looked at this and said, wait, replacing a solid database system with a bunch of loose files? That's basically a massive step back to the 1960s? So their solution was elegantly simple. Take all that metadata and put it right back where it belongs, inside a highly efficient database catalog.
And the impact of doing that is wild. By keeping metadata in a database catalog and utilizing data inlining for small insertions, you completely bypass the need to read thousands of tiny metadata files on S3 just to run a single query. What does that mean for us? An astonishing 1,000 times performance difference when running aggregations. Yeah, you heard that right, 1,000x boost. It translates directly into insanely faster queries and, of course, way cheaper cloud bills. Moving on to Section 2, the 1.0 milestone, spec versus implementation. Now, with that massive performance baseline established, what does hitting 1.0 actually signify? Well, the crucial thing to understand here is the hard split between the specification and the implementation. DuckLake 1.0 means the specification, the actual rules and SQL queries dictating how the lakehouse is managed, is now fully stable and guarantees backwards compatibility. The implementation, though, like the actual engine and extension reading and writing the data, that's going to keep evolving rapidly. But stabilizing the spec is a massive deal. It means independent developers can confidently go out and build their own readers and writers for systems like Spark or Data Fusion without the constant fear of the foundational rug being pulled out from under them. All right, Section 3, killer new features. What's actually new in DuckLake? The team definitely hasn't been sitting on their hands leading up to this release. They've dropped some incredibly powerful updates. First up, checkpointing. Because features like time travel and change data capture mean data is never really deleted, checkpointing swoops in to solve the huge maintenance headache of managing all those leftover fragments. Next, they rolled out full geometry support. It's totally compatible with GeoParquet, complete with file-based pruning. Then we've got set sorted by, which lets you actually sort your data by specific columns during compaction. And finally, add files. This is super cool. It lets you instantly register external Parquet files right into DuckLake, even if they were originally written by a totally different system like Spark. But I gotta say, perhaps the most hyped new data type is something that devs lovingly refer to as JSON++. So why all the hype around the variant type? Look, standard JSON is everywhere, sure, but it has some massive limitations for big data. It completely lacks native database types, and the compression is just awful because of all the constant text repetition. The new variant type basically fixes this by acting exactly like JSON, but armed with a full-fledged database type system. It natively supports dates, timestamps, UUIDs, the whole shebang. Behind the scenes, DuckLake dynamically shreds this semi-structured data into native columns. That gives you incredible compression, file-best pruning, and near-native query performance on data that is, frankly, quite messy. Which brings us to Section 4, real-world DuckLakes, production deployments. It's always fun to see how this stuff actually gets used out in the wild, and we are already seeing some brilliant deployments. MotherDuck, for instance, is offering managed cloud hosting for DuckLake. It gives users a fully managed ecosystem, integrating seamlessly with tools like dbt, while ensuring the underlying data stays in a completely open format, so zero proprietary vendor lock-in. Then, on the totally opposite end of the spectrum, companies like MadHive are building what they call frozen duck lakes. They're publishing highly compressed database files alongside Parquet files over HTTP. This lets them distribute an entire multi-table database, complete with views and macros, through just one single file entry point. It's incredibly efficient. Okay, let's talk about section 5, the iceberg puzzle, getting from Duck Lake to iceberg.
So we have to address the elephant in the room, Apache Iceberg. It is insanely popular right now. So naturally, everyone wants to know how it plays with DuckLake. Now, reading iceberg data into DuckLake, that's largely a solved problem. DuckLake just uses a zero-copy metadata translation to instantly turn Iceberg's file zoo into a native DuckLake catalog. Pretty slick, right? But writing a DuckLake table back out into Iceberg, well, that presents a fascinating and honestly deeply complex technical puzzle.
The friction really boils down to a fundamental clash of formats. To beat this small file problem when running time travel queries, DuckLake uses this brilliant innovation called partial files. Basically, a single physical Parquet file can hold data that belongs to thousands of different historical snapshots. The catch? Iceberg currently doesn't support partial files at all. So if you try to export your DuckLake back to Iceberg, you just hit a brick wall. You either have to nuke all your time travel data and only export the latest snapshot, or you're forced to completely explode your storage and basically reinvent the very small files problem DuckLake was built to fix in the first place. It is a severe architectural clash, and it's being heavily debated by the community right now.
Finally, let's look at Section 6. What's next for 2.0? Looking ahead.
Even with those integration hurdles, the team is charging forward. The roadmap for DuckLake 2.0, which is probably about a year out, is looking incredible. The absolute most universally requested feature is branching, often pitched as Git for data. Think about it. Just like with code, developers want to spin up parallel branches of their data lake to safely run experiments, test out schema migrations, or trial new pipelines, absolutely without duplicating those massive underlying data files. The big debate right now is whether to bake that branching capability directly into the 2.0 specification itself or to build it as an external layer.
Also on the horizon for 2.0 is native role-based access control, or RBAC. Sure, you can secure DuckLake today using underlying tools like Postgres or S3, but baking RBAC right into the core specification, that is going to create a unified, seamless security standard across any system you're using. And moving from security over to performance, the community is really pushing for incremental materialized views. Since DuckLake already supports change data capture out of the box, natively linking that capability to materialized views for automatic, highly efficient recomputations just makes perfect sense as the next step.
So what does this all mean for us? By pulling metadata out of thousands of tiny files and putting it right back into a highly structured database catalog, DuckLake isn't just giving us a cool new format. It's fundamentally challenging the entire trajectory of big data infrastructure over the last decade. It really forces us to step back and ask a provocative question to take away from this explainer. Is standardizing back to our database roots actually the ultimate, most elegant solution to modern big data complexity? Definitely something to chew on. Thanks for joining us for this one, and we will catch you next time.